just because someone has a difficulty with learning or acquiring math skills doesn't mean they cannot. It just means that teaching them or guiding them might be a little different. And so we are going to be looking at the multi-sensory approaches to teaching adults with MLD. And this is where the strategies and applications really come in. And they're going to come in these different categories. I know. So they're each individually going to be looked at. This is where we're going to get sort of end heavy. There's a lot of stuff, information, but still feel free to ask questions. So we have things in number facts, mental math, symbols and language, visual-spatial, areas, cognitive development, working memory, rules, procedures, and a verified understanding. I'm just going to jump right in, but we should be mindful of the possibility that a learner with MLD may use different techniques and may benefit from different from different subsections that we have here. So starting with number facts, there's different approaches to counting. If you have had a learner that has an MLD, you may have seen some of these. There's a counting on and a count all. So if I say 5 plus 3, a learner with an MLD might say 1, 2, 3, 4, 5, and then they might say 1, 2, 3. And then they might say 1, 2, 3, 4, 5, 6, 7, 8. That's sort of a count all approach. Gets them to the correct answer, but there might be a more efficient way and encouraging to do a counting on. So you go 1, 2, 3, 4, 5, 6, 7, 8. I've seen the same thing with subtraction. If I have someone trying to go 10 minus 7, they'll go 10, 9, 8, 7, 6, 5, 4, 3. And I've got my 7 taken away, I got to 3, but really you can count up to 7, 8, 9, 10. There's that difference that I was looking for. So sometimes it's what works at the time. If you're subtracting a small number, then maybe, yeah, just subtract it out. But if you're subtracting a much larger number from, it might be easier to count up. And neither should be discounted. You might also see in students with a MLD, what I just talked about can be done either on paper or on fingers, but or even out loud vocally. But you might see a common retrieval problem that occurs. So if they're given something like 6 plus 2, well, they see the 6 and they see the plus, so they say 7. Or they see the 6, or they see the 2 and they see the plus, so they say 3. And they might be going through sort of a sequential approach. And if that's the case, then you might be dealing with someone who has an MLD and specific in the number facts area. So I would encourage practicing often, but in small quantities. Again, what I mentioned earlier, the big page of 40 questions might not be the best way to approach all students, and some might feel overwhelmed by it. With smaller questions, it gives the instructor more of an opportunity to guide and for the student to not feel quite so overwhelmed, to work a little independently. And it's repetition that works in a supportive way, that develops a self-confidence instead of a typical sheet from a really heavy textbook. Here is 50 questions on one page. There's also real-world ways of connecting some of these basic math problems, like 2 2s. You got 2 tires in the front, 2 tires in the back. That's 4 tires on a car. 12 and 12. You got your 12 times 2, the 12 hours in the morning, in the AM, the 12 hours in the PM gives you 24. With some of my students, I do 13 times 4, and boom, that's a deck of cards. You got your hearts, your diamonds, your clubs, and your spades. That's 4 suits, and there's 13 in each suit, and so you have your 52. So if you can connect those to real-life examples, then it can make it a little bit easier for them to understand, or at least give them something to log in their memory to access in the future. So some activities that you can use in the world of number facts is, hey, get familiar with numbers by getting a bunch of pennies, or maybe I should change that to nickels, but just arrange them by date, right? Just seeing the numbers in order can really help someone with a low understanding of the number facts. Using graph paper for alignment, and in the first session that we did this, someone also suggested that regular old line paper can become graph paper by doing this. And I was like, yeah, that's exactly what I'm talking about, because when you're adding numbers, some students with poor penmanship might have things look like this, and then they're not sure where things are lined up. Graph paper, if you haven't used it yet and you've got someone who just is making what I would call little goofs, It's not a lack of understanding, but it's not lined up properly. Well, if you have access to graph paper, you have your columns that you can line up, and so everything is just tickety-boo. And if you don't have access to graph paper, you might have access to line paper, and so line paper can easily become column paper by just reversing the direction. There's a few different mental math techniques. If you haven't seen David's resource on the Nassau website, I highly recommend it. Some of the mental math multiplication I still use every month without fail. Because students say they need to know their multiplication table from 12 to 12, but don't. And when that happens, I say, all right, let's do some mental math. Some of which are things like whether it's doubling for multiplying by 2, doubling for multiplying by 4, using the tic-tac-toe method for the 3. The fingers, has anybody not seen the fingers? I think by now I think everybody's seen the fingers. But I don't know if your mind's been blown in the other way, right? And Facebook is blowing this up all over, so I'm going to, in case you're not on Facebook, now hold on to your shorts. This isn't done, but I know it's pretty impressive so far. You see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then just backwards 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, you've just done your multiplication of 9 table, 9 times 1 times 2 times 3 times 4 times 5. The mirror image, 4, 5, 5, 4, 3, 6, 6, 3, 2, 7, 7, 2, 8, 1. And the reason it works is because 0 plus 9 is 9, 1 plus 8 is 9, 2 plus 7 is 9. All of these, when I show my students, I sometimes pull out the different techniques, and one will work and one might not, but they're blown away by something. They haven't seen it all, and maybe just having their mind blown in that way it'll stick with them, and it'll be like, oh, all I have to do is to go 9 times 7 and say 1 less than 7 is 6, and then figure out 6 plus what gives me 9, 63. That's all I have to do. Oh, I did that right here. And what we're really doing with mental math multiplication is taking that process from figuring it out, which is like in the back of your brain or whatever, to having it right there at the front of your brain. So even though Rachel might have one long time ago not known how to spell her name and struggled with the R and the A, now it doesn't have to think about it, she just writes the name out. Well, that's the same sort of idea that we want, so to be able to pull these facts directly from the forefront of your mind. I've seen people with different learning differences use colors to coordinate and organize, and if place value is an issue, you can use different colors and highlight the different columns of whether it's the ones, the tens, the hundreds, the thousands. Pen blocks are also great for place value. So definitely include as many strategies as you can from your teacher's toolbox, and that toolbox will build. Students, in fact, have brought me different techniques that I now use with other students. So that's number facts. Mental math we've talked a bit about, but something we haven't talked about is fact families, and I can't get over this enough. If you're teaching someone who's acquiring English as an additional language and you're teaching them the word act, well, while you teach them the word act, you can teach them the word react, or acted, or acting, or acts, or actor, or reaction, and all of that stems from the same root word of act. Well, it's sort of like how you can learn a lot from a fact family. And they work with addition and subtraction. So if you know that 3 plus 4 is 7, well, lo and behold, you know that 7 minus 3 is 4. And same with multiplying and dividing. 16, you know that that's 8 times 2. Well, you now know that 16 divided by 2 is 8. It's like acquiring a few things at once. And so when they learn that 13 times 4 is 52, well, lo and behold, 52 divided by 13 gives you that 4. And so sometimes showing them that helps them understand that process. I've seen it in triangles, and it's often a fun way to visualize it.
Can I just add one thing?
Yeah.
Andre? This is perfect what Andre's saying right here. This fact family work is something I really stress in level 1, and it's complemented in level 3 when we go into signed numbers. And where signed numbers, the rules are kind of funky. Why when you subtract a negative from another number, why do you change the signs and all that? It's kind of funky to try to understand where that rule comes from. We build it from fact families. So we say, you understand how to add these numbers, now rearrange it using your fact family numbers and knowledge and write it out this way. And now we can come up with the rules. So when you do this work in level 1 with whole numbers, I'm telling you right now, you're helping your learners when they get to level 3 and they have to do signed numbers. So if we're all kind of on the same page, doing the same thing, it helps everyone.
Absolutely, David's right. The focused practice involving these fact families they can definitely improve the learner's ability to access all these arithmetic facts at the time and later on. So another method that I encourage for my students to take ownership of all of the skills that they're acquiring is through a math journal. If they're wanting to retain the information, and you know math is just concept upon concept upon concept, and sometimes it can be overwhelming, and what they learned 3 months ago they might forget because they've learned so much more. Well, a math journal that they create helps them own that, and they can use it as a reference guide as they move on to more complicated concepts. This journal can be filled with tips or rules or examples, hints, formulas needed, but it reaffirms the skills that they've newly acquired. It can lead to improved reaction time and their retrieval ability, the retention. It's the example of if I sell this chair to Dave and I say it's yours for $5, and Dave's like, sure, chair, nice cushy chair for $5. But to Dave, that's just a $5 chair. He might put it on his patio, gets rained on, he doesn't care, it's a $5 chair. But if Dave goes home and makes this chair, he'll be like, look at what I have created, this beautiful, comfortable chair, I'm so proud of it. And that's what I mean by the math journal. A student that creates their own math journal feels that ownership, feels that pride of acquiring those new skills, as opposed to the instructor who just hands them a photocopy and say, here, keep this in with your binder and your notes, and maybe it gets lost on their way home or gets fueled their fire for whatever reason. But something that they've created, they own a little bit more. Also, for mental math, estimation stations, like we've seen this before in grocery stores. If you've got the can of jelly beans and you guess the right number of jelly beans, you win the jelly beans. That's awesome. But you can mix it up a bit. Put in Cheerios, put in pennies, put in rocks, you know, change it up, change the size, the different shape of the container, marshmallows if you don't have the others, or whatever you have handy. And it can be just a fun activity that, you know, they can get a prize for. I don't know how we're doing in time, but I hope we have like 20 minutes left. So activities involving mental math should be interactive and physical if you can. Things that you can do is like, how wide is this room in meters, and then you can measure it with a meter stick. You can also try to identify how long a minute takes to go by with your eyes closed without looking at the clock and seeing how close people are. I use some great fun things. A student, or I can't remember who, I think it was at a conference, I never heard this before, but if you want to find the area of a pizza is a circle, so all you have to do is go pi times radius, and you get your area. So pizza. You need a little bit of imagination to get the R out of the Z's, but it's not so bad. We should be encouraging our students not to just see counting as 1, 2, 3, 4, 5. Start at 8 and go 8, 9, 10. Start at -3 and go -3, -2, right? If you start anywhere, then they start to realize that it doesn't matter where I begin, the patterns are the same. So, or count in 3s, count in 7s, count in like the awesome cadence of 5s I mentioned earlier. You've all seen the alligator or the piranha or the dragon or, I don't know, the crocodile. I think I've heard everything of what, you know, hungry eats the big number and not the small number. Some adults don't like it because it's juvenile, so whether they use the large space is for the large number or the small space is for the small number, pointing to the small number, these are all techniques that can work, but nothing engages them more than this following one. And if you'll do me the favor of helping me out with this research, I'd really appreciate it. So you might have all seen the people on the street who have the backwards hat and the chains, and they're all like, yeah, what, and this and that. So I think in their circle of friends, maybe it's not cool to be expressing math techniques, and so, but they have to get it out somehow. And so I really believe they're showcasing their knowledge of inequality by doing the I'm greater than all of these lesser than peoples, and I'm bigger and better than all the smallers. So next time you see somebody be like, yeah, what, just if you do me a favor and go up to them and say, excuse me, young sir or lass, are you exhibiting the inequalities of, you know, the symbols? Because I think that's might be what you're doing, and some math guy told me that might be what you're doing, and because I really think that's what's going on in some circles in the cultural. It could be. It's still in the research is in process, but yeah, I mean that's another way, right? If you want to be like, yeah, greater than right here, lesser than. Sorry, Elaine. Symbols and language. Now here we're looking at numbers being used as labels to measure something. Now to create meaning, you want to look at the language that's used. You want to provide a rich description and to understand the meaning and the process to make the invisible visible. We're using terminology, and we're going to talk a little bit about this so that it's not just meaningless symbols. We want to be able to understand the terms we're using. So if I was to use something like a numerator or a denominator, a proper, improper, I might speak of what these are. If you're teaching an English language learner, please tell them what a dime and a nickel and a quarter and a loonie and a toonie is. They might not know that. We might take that for granted that we all know what a loonie and a toonie is, but often I have really good students who aren't sure what a nickel is. That the 5 or the 10 or the quarter? And that there are different ways of saying this, right? 6:30 can be half 6 or half past 6 or 30 minutes after 6 o'clock. So we have to be mindful that that there are different ways, and if you shuffle that up a little bit, then you're not sticking to one thing always, and then the learner might not just, be thinking there is only one way to express something. One of the biggest things I talk about is math merriment, and it's a way to engage learners. You absolutely will have their attention if you add a little bit of humor to your lesson, and it enhances the learning environment. So another thing that came out of the practitioner training program was this little stop animation video.
Welcome to the wonderful world of math, where learning can be fun with just a little imagination. Before we get to our triangle friends, it's important to understand these 3 basic angles. Let's start with an acute angle. Oh, look at me, I'm a cute angle. I'm so small, I'm an acute angle. Not like me, I'm obtuse. I'm so large, I'm obtuse angle. Oh, right angles. Our triangle man friend is equilateral triangle, easy to spot with his equal sides. When asked, he said, Isosceles, what a triangle, her 2 legs are the same length. Not like scaling, poor scaling, none of his sides are equal.
I mean, that was a little 45-second blurb that kind of shows how fun can be put into it. I've used the example in class where, you see Celise. I saw Celise, she's a triangle with the same legs. Yep, that's right, 2 legs, exact same length. And poor scaling, he's got nothing going right with him, right? Nothing's equal, no angles are equal, no sides are equal. Kind of feels like he's got that, scaling disease or whatever it is. And even in class, I use I tell my students, say all right, all L's are right angles, right? All right angles are L's, right? All right angles. And it's that repetition, and it's fun, and they finally get it when I say it enough times that all right angles are L's, right? All right angles are L's, right? Right. So it's, just a little bit of fun, and not a whole lot. You can, only go so far with math and fun, but, a little peppered here and there will make the learner more engaged, the environment more positive, and if nothing else, keep them coming back to math class. So some activities that you can use with symbols and language, math word wall. I've got one in my class. Doesn't quite look like this, but this is great. It's got even the color separation, so subtraction is all green in this case, or multiplication is all purple, and you're understanding the different words that can be used, and they can use that as a reference in class, right? So when they see something like how much more, they know that this means subtraction. When they see how many of something will fit into something else, they know that that means division. And it's not as rigid as there's always going to be the case, but it's a starting point so that it makes them feel a little bit more comfortable. Often I see them say, oh, it says more, it'll be add. Well, then I is it how much more? Or even more importantly, how much adjective-er. Like I'll say how much more tall, how much more big, how much more long, even though that's poor English, it still reminds them that it's subtraction. So if it's how much bigger, how much longer, it's still subtraction. And also asking the learners what a number means to them allows them to think about a number in different ways. What does the number 9 mean? What does the number 12 mean? What are these numbers to you? If nothing else, it makes them a little bit more familiar and a little bit less anxious when dealing with certain numbers. And talk to them, discuss to them how the skills that they're acquiring will transfer as they move on to further concepts. A think aloud technique is quite often used. What it is basically explaining and going through steps, thinking something out loud. So instead of just reasoning it yourself, and you can do this or you can encourage them to do this. Here's an example of it being done with long division, just following 4 simple steps of how many times something goes into, the outside number goes into the whatever we're talking about, moving on through the 4 steps of multiply, subtract, and then drop the number and drop it like it's hot. Or if you remember the maestro, drop the number, and then just repeat that, and they'll appreciate it if they remember who Maestro Fresh Wes is. I'm moving through because I don't know how we're doing. Probably good. Yeah, that's right. Drop the number. Yeah. Oh, we're good. We're good. I got a whole half hour. So yeah, on another thing, speaking of pop culture and math, I think I have said more times than not how to change decimals to percents and percents to decimals. Crisscross will make you jump, right? And I don't know if anybody remembers crisscross, but crisscross will make you jump. And eventually the adults will tell you that crisscross will make you jump. So if you're changing from the letter D, which is at the beginning of the alphabet, so to the letter P, which is a percent, you're moving in that way. Or if you're going from percent to decimal, you're moving this way. But regardless, crisscross is going to make you, and you're going to jump those decimals 2 spots, always 2 spots. So we've talked about symbols and languages and mental math and number facts. We still got half an hour, so I'm moving along. And we are now approaching the visual-spatial. So one thing we often see is a number line. And we think of the number line as a horizontal context. In Canada, we understand that the temperature thermometer can look like this, and you can have negative because sometimes in winter it's cold, and then it can go up to warm. And so especially when you're dealing with integers, I found adult learners who have experienced the winter in Canada will appreciate thinking of it as, all right, it's -3 and it warms up 5. Okay, I can understand that I was at -3 and I'm going, and they don't even understand, or they don't even realize that they are using integers, right? They just think that it was cold out and now it's warmer, it's +2, I'm a little bit happier than it being -3. So visualizing something that can work for them, and whether it's your bank account being in the red or you're going underwater, I mean, there's other techniques, and each learner is different and unique, and so one thing might work better for one person than another. So I would encourage instructors to stimulate the learner's tactile visual senses by using different learning tools or manipulatives. This is my student workstation in my classroom. You've already seen me use the little mini whiteboard, which comes in super handy. Got them available for learners. The geoboard's great for when you're dealing with things like area and perimeter and two-dimensional shapes. You see those 10 number blocks that we were using? These geometrical shapes, if you get a hand on them, they're amazing when you're dealing with three-dimensional shapes. If not, you can build them. You can make your own out of paper. The fraction tiles get used probably more than anything, as well as the blocks that show you the percent and the decimal version of fractions. All of these I highly recommend. And if you can get a hold of the Canadian money as opposed to kicks the Monopoly money's butt, because it looks just like actual money. And they're like, I'm going to pocket this and buy myself a coffee. I'm like, oh, you can't do that. But yeah, I know now that the pennies are exactly. Well, the nice thing is now there's room for the toonies. So just shift everything a bit. I would encourage when you're giving worksheets not to make it too cluttered. I think I mentioned it already. Whether it is geometry or just a series of exercises, leave some space. Just having so much black ink staring back at you can be overwhelming. A little bit of white goes a long way in being able to make it more comfortable. In fact, there's other stress reducers that you can use. If you can't get a hold of a whole bunch of pink paper or blue paper or green paper, you can often easily get those transparent dividers. And for a learner that has difficulty focusing, find if you have whatever color that works for them. And there they now don't have a white sheet of paper. It's a blue or a purple or a green or a pink. And it just makes it a little bit calmer for them to take in. So thinking about how something is presented is definitely one thing that should be considered when providing students or learners with exercises and papers to work on. So activities dealing with visual-spatial. We talked about making actual real 3D shapes, relating it to real-life object. A cone, that's an ice cream cone. That's a pylon. A box, or sorry, a rectangular prism. It's a box. It's a tissue box. It's a triangular prism. You know what that is? It's a Toblerone bar, or it's a roof of a house, or and laying things out so that it makes it accessible, so they can visualize. If the place value is helpful, to have them draw it out on a piece of paper and see that there's 1, 2 spots, or the tenths and the hundredths and the thousandths, recognizing those patterns, showing them that pattern, and also really providing stuff that hits home. Someone mentioned earlier about adult everyday math. Grab a menu from a restaurant that exists, instead of just some random thing offline. Grab a flyer from Sobeys or Superstore. Use those deals, and it might hit home a little bit more. The way you have to figure out discounts, or one of the best is sometimes when you're like, if you buy these items and you use up this kind of much, and you get an extra 50% off, and then you send in a coupon and how much more you can save. These are really real world techniques that can cut down on the grocery bills. I often use coin equivalencies, so relating things to money is one of the ways that really engages the learner, because once it's money, it makes sense to them for some reason. So I would ask, how is your classroom visually stimulating? I don't have a picture of my geometry, but I do have a geometry in my classroom that has different formulas for finding the volume and the surface area of three-dimensional shapes, as well as area of two-dimensional shapes. And sometimes just something visually stimulating can increase or the learner's engagement. So I mentioned before that when the understanding breaks down, a student can feel as if they're drowning in the deep end. So if that anxiety occurs, they're going to avoid the situations that cause it. The best thing that we can do to help our learners are to make sure we know what they do and what they do not understand. So that requires a little responsibility for us to keep a monitoring on our students, so that if something happens, we're there to be able to correct it. And I think I'm jumping into cognitive development. So yeah, identify and correct those misconceptions ASAP, right? It's a two-way street. Not only is it the responsibility of the learner to tell you when they don't understand something, but it's also the responsibility of the instructor to keep an eye to see if they are moving in a direction that isn't in their best interest, so that you can go back and say, so explain, how we are getting here, right? Don't just put a big red X on it. Be like, all right, help me understand this process. Well, why did you choose to do this? And ask them questions. Guide them to in the directions that you want to see. So I would say or remind us that we have to start with our basic skills. We have to build on those. There's a scenario of that's coming up. Okay. Yeah, you want to be able to make correct the action before further lack of understanding occurs. So if you want that complete understanding before moving on, it's a responsibility to sort of always stay engaged with your students, so you know that they're moving forward. Small group instruction can help this. Sometimes we get lost in the full class instruction. So if you're dividing your class into groups and some people are working together, well, you can not only work with a smaller group a little bit easier, especially if they're all working on the same concept, but then they can help each other. Nothing really helps a learner learn more than helping another learner learn, right? And it sort of solidifies what they have learned. And so if you're separating your class into groups based on where they are, that can be beneficial. And I've also, you kind of see them helping each other out. And if they're not writing a test, I honestly don't see that there's anything wrong with that. But it definitely might make your task less challenging to have a little group of 5 or 4 than a class of 20 and trying to sort of monitor them all simultaneously. Activities in cognitive development, reflective practice, the self-check is very useful. You want to be able to help them improve their procedural competencies, which means that you want them to be able to apply what they've learned, so that help them check it, then they're learning to help check it themselves. We've talked about before the 1-minute passing with the eyes closed. That's another one, a great exercise. And give pause. I mean, I know I've been barreling through this, but in class, if you're teaching concept upon concept upon concept upon concept, it can be just a wave of information and people can tune out. So you want to give pause, make sure the understanding's there, ask questions, engage your learners, so ensure that the understanding is there. This will definitely help their clarification and acquisition of the knowledge, and it'll help you be sure that they are understanding, as opposed to just, oh, I've taught them because I blah, blah, blah'd it to them for 30 minutes straight. Obviously, they've learnt it. Well, not necessarily. Unless you've gone that back and forth, you might not have noticed that some people did tune out and might not have gotten everything that you've wanted to share with them. But if you keep them engaged, if you ask them questions, if you tell them, okay, now you give me an example, well, then you're not only keeping them engaged, but you're making sure that the understanding is being acquired. And be open to different ways. I saw this online. I thought this was kind of cool. What's 3 times 9? Well, it's 3 times the square root of 81. And what's 3 divided by 81? Well, it's 27. And 3 times 9 is 27. It's a completely different way of thinking about it. But you know, if somebody, I tell my students this, if we're all trying to, now I don't know Truro very well, but where I work, it's not that far from the Halifax Shopping Centre, and there's a Tim Hortons in the Halifax Shopping Centre. Everybody can relate to meeting up at Tim Hortons. So just because one person might take one shortcut and the other person might go up one way and the other person might walk or someone might drive, if we all get to meet at Tim Hortons, then we've accomplished our goal. We've all met at Tim Hortons. So just because one learner is doing it one way, I mean, there are different methods out there, and some of them we're going to be talking about as well. But if somebody got to 3 times 9 is 27 using this method, I wouldn't fault them. They got the answer as 27. And maybe somebody else did 3 sets of 9, or, you know, yes, I want to be there to encourage and efficient ways of getting to the answer, but sometimes, I mean, we have to understand our adult learners have lived on planet Earth and have functioned and using the skills that they've acquired. So they're coming with a lot of knowledge already, and we should be supporting that and not necessarily saying, well, you should be doing it this way. So I want to just highlight that that is just as important as you know, showing them other techniques, is to celebrate what works for them. So the working memory deals with the execution of the appropriate operations, also deals with the processing efficiency. So it can be lower for high anxiety individuals. The speed of fact retrieval can contribute to the tendency to undercount or overcount. So ideally, we want that to be a nice, appropriate, what we talked about earlier, to be able to get those facts in, right from the forefront of the mind. What David mentioned earlier, those things that we learn in level 1 will come in play level later on, because if you're still struggling with like line, I'm going to draw 5 lines of 7 and then count them all up, well, you're slowing your whole process down. If we can find a more beneficial way to get 7 times 5, then that will benefit you as you move up through the levels. So you want to be able to provide a good frame to evaluate their accuracy through guiding their procedure. Again, we're building upon math facts and being able to retrieve the information that they've attained. And this can be moderated by their confidence, right? If they have learned how to self-check, if you're giving them the confidence, if you're encouraging them through positive feedback, then they will know that, hey, you know, I'm confident that 7 times 5 is 35. I've checked it on my calculator if I need to. And eventually, I say this quite a bit, that if you look up the word enough times, well, you won't have to look up the word enough anymore, because you know how to spell it. If you have to look up what 7 times 5 is on your multiplication table enough times, well, eventually you're going to know that it's 35. And then that will go to the front of to access those facts, the multiplication fact. So we've got some great activities here for working memory. There's different methods for multiplication. The last method, if you haven't seen it, David's got a great resource on the NASAL website. But if you haven't seen it, it's basically, here's a 2-digit number multiplied by a 3-digit number, so 3 boxes by 2 boxes. So that's where you start with 1, 2, 3, 4, 5, 6 boxes. You slash them all into diagonals, kind of like on a bowling score. And then you just do easy multiplication. So you know that 3 times 2 is 6. You know that 8 times 3 is 24. 6 times 3 is 18, and so on. Now you've got these lovely diagonals, and then you're just adding up those. So there's 4, there's 12, the 1 gets carried over, and we add up to 17, the 1 gets carried over again, and now we have 9,724, which is what 286 times 34 is, and not using a necessarily old traditional way of multiplication. Nothing against the old traditional way, but sometimes that doesn't work. The order of operations, back in my day, if I wanted to win the bicycle, we didn't have iPads, so it was often a bicycle, I had to solve a skill testing question. Nowadays, they've got this awesome word named BEDMAS. I'm sure all of you have heard of it. If not, it basically just means the order in which you have to do things. And so you have to begin with your brackets. Your exponents are the second most important. Divide and multiply is more important than add and subtract. Add and subtract is, in fact, the last thing that you do. And when you have something that's like subtract, add, subtract, you have to do it from left to right, just like you read. So I use these because, you know, even if it's a cheeseburger that you want to win and they ask you a skill testing question, 10 minus 3 plus 2, is that answer 5 or is that answer 9? And everybody sees the answer is 5. No, you lost the iPad or the bicycle, because even though 3 plus 2 is 5 and you take that away from 10, that's incorrect. You actually have to go 10 minus 3 is 7 and then add 2 is 9. And the next one, 10 minus 3 times 2, is that 4 or 14? Now you might be able to see how someone might think that it's either of those answers, but 4 and 14 are very different, and only one answer is correct. And the answer is 4, because you have to follow the order of operations that says that multiply is much more important than subtract. And so teaching that, I mean, BEDMAS wasn't around when I was learning it, but it's something I use now. They've gone through quite a range of names for this. PEMDAS, PEMDAS, PIMDAS. BEDMAS, I think, just rolls off the tongue easier, so that's the one that seems to stick. But I would also encourage using instructional technology. Like, if you check out this presentation when it goes on the website, which I hear it will, you get awesome things like using an ATM with your students, like insert card, and then what language, and then if you don't know the PIN, guess what it is? 1, 2, 3, 4, and then hit OK. And then you can do whatever you want. If I want to be a rich person, I'm going to withdraw. Oh, there's a fee. I understand that. I want $150 right now. Well, oh, nope. That's. I don't think I'm going to get that much. But if I want 150, that would be nice. And oh, I can't, because I understand that they only dispense 20s. All right, I'll take 120. And this, I'm just going through it quickly, but you can get this to work. Not only that, it tells you, great, there's your cash. Would you like a receipt? There's your receipt. You can print this. You can add to it. You can withdraw. You can do all kinds of things. You can deposit. And this is all online through, I think it's the Newcomers Financial Kit or whatever. But the link is directly there off of this presentation once it goes up on, is it the Literacy Nova Scotia website, the idea that it will go up? Perfect. And there's the debit machine, right? For those of us who are no longer carrying cash, the experience of using a debit. Now, a lot of us are consumers and use this, but some learners at low level want to know how to use all of these machines. And here are perfect examples on what you can do, the kind of things that you'll encounter, so that you know the kind of questions that you'll be asked, so on and so forth. And then, again, if you're not sure what your password is, well, it's 1, 2, 3, 4. Life's not that easy, but obviously you would talk about approved, congratulations, this is how much I have. So there are great techniques that you can use, and I'm sure alternatives come up. Now we can talk about rules and procedures. This can show up when you're reviewing key math words. So that, we talked about this earlier, like preempt. If you're going to be talking about isosceles, maybe you bring up the word isosceles, because boy, it might not be so hard to say, but spelling it is a whole other ball game. So get them a little familiar with it, but also explain words like part of and whole, and whether it's through examples like a piece of a 6-piece pizza, like 1 out of 6 is a part of that 6-piece pizza, or 37 cents is 37 of 100 cents, so you're seeing what parts of a number are, and explain those harder terms. Like, how many people in their daily lives have heard the word quotient? No, nobody. Who's using the word? David doesn't even use the word quotient. No, I mean, nobody does, right? An answer to a division is an answer to a division. What is the quotient, right? So, I mean, I'm not saying don't teach them the word quotient, but make sure they, they understand the context and how common or not common. I definitely teach the words numerator and denominator, and for those of you who don't know which one's which, you just say it out loud. Numerator goes to the top and denominator goes to the bottom. It's like, say it and it happens to float to the top or drop down. But to be honest, Adults want to learn quickly, so I say top and bottom, because then that's them acquiring those skills. We talked about the think aloud techniques. As you're working through problems, on a board, talk out loud as you're working through it so they see the process of reasoning, and so that they can then use that same process when they're working out problems. And keep it interesting, relate it to the learners. Do use techniques that work for them. If you have someone that is interested in plumbing, well, then there's lots of ways to make math and plumbing, and math shows up pretty much everywhere. So whether it's career specific or life specific, it's not a hard stretch to find a way to make math show up in their everyday life. Activities. When you're dealing with word problems, you can highlight key words, and word problems are really a way to transfer all the skills that we're learning to real-world situations. I mean, word problems should really be world problems or real-world problems, because they're problems that we encounter in the real world. Often checklists, students that we talked about when we did the long division, there was 1, 2, 3, 4 steps. I mean, some students love steps. They want steps for everything. And if it helps them, then encourage it, right? Write down the steps that works for you. And their math journal is a great place to put that. But this idea of making sure the answer makes sense, this is talking about is the answer reasonable? Especially if they're doing an exercise page or an assessment, go back and look at it. If you're looking for the average of a group of numbers, and the smallest number is 12, and the biggest number is 52, is your average going to be 306? Well, that just doesn't seem reasonable. And it's not a huge leap for a learner to see that. It should be somewhere in between the 12 and 52. And so they see 306, they say, oh, you know what? Maybe I forgot a step. Oh yeah, I forgot that divide step. And if you can catch them, or if you can encourage them to catch that, then they're taking on responsibility. Like if you know that you're one of those people who has difficulty with your, or there, and you know that when you're writing, you're paying a little bit extra close attention when you're writing the word there. Well, if you know that where your key mistakes happen, if you're always missing up the average, well, then you can pay a little bit of extra attention when you're doing an average question. Because you're starting to learn your little quirks or the wrinkles that need to be ironed out. Also, labeling work, whether it's through a picture, like a visual diagram to supplement your word problem solving, or if you're using ratio proportion, if you're comparing shadows with the height of something, labeling that the shadows are going to go here, the heights are going to go here. We're comparing ratio of a person's height to shadow, or a building or a tree's height to shadow. If things are labeled, then they start to fit in a lot clearer. Put the onus on the student. You know what? You create a problem. Go for it. I'm done putting problems in your hand. Why don't you put one out here? And then it gives them a little bit of responsibility, and it makes them feel a little bit important, a little bit of power in their hands to be able to create a word problem for others to solve or for you to solve. This is a great example of highlighting important information in a word problem. Some people use different colors. Some people will underline and circle. Some people will just take out information, or whether it's extra information or needed information, put an X if it's not needed. But there's lots of activities that can be used for rules and procedures. And we're into our last one, which is great, because I think we're around 10 minutes left, which is fantastic. So I'm going to have to say that, math, like a house of cards, bottom layer has to be firm, accurately constructed to support the upper layers, right? So when we're dealing with math, every stage is so key and dependent on the last. If you don't have a really strong foundation, then you can't build upon it. So those number facts that we're learning in level 1, they are going to be used to build upon, and we need to make them really strong. So if you have them in level 1 and level 2, reinforce those, because if you have a lower level that's shaky, you know what's going to happen in your house of cards? It's just going to all fall down. So what we want to do is to tighten that gap, make sure the understanding's there, so not let it get wider and wider and wider. If we lose them right from the get-go, then all that's going to happen is it's going to be more difficult to make that connection and reach all the way back. But if we have a very, very strong foundation that can build concepts upon, once they get to levels 2, 3, 4, and beyond, they will have such a strong foundation that they will be able to have their house of cards build upon it. It is a cumulative process. It's something that builds upon each other. One thing I just want to say quickly is that used this example a few times, but in English, if somebody's name is Stephanie and I write Stephanie and it happens to be Stefenee or whatever, and there's no other Stephanies, and I say, who's this? And Stephanie puts up her hand. She's like, but that's not how you spell my name. It's PH, and there's an IE, or it's an A. But Stephanie knew it was Stephanie, because, you know, enough. If I don't feel like writing enough, I'll write ENUF, and you know what I'm talking about, because it says enough. But if I want 9,763 to be my answer, and I write down 9,342, well, that's completely different. Now, everything is now going in the wrong path. So these little glitches, you have to be so careful when writing down numbers, because you can't just, I meant this. Yeah, but just because you meant that doesn't mean that came across. You change the number 4 to a 9, and now all of a sudden everything's different. Even if they're transferring that information from an exercise or a test onto their paper and they miss a number, well, now they've gone on a different path altogether. Great if their method is working, but at the same time, one wrong number can send the rest of the work in the wrong direction. I really encourage people to track instructors to track the progress so that you can identify where a student needs extra learning. And make sure we talk about this, establish that understanding before moving on. Activities that you can use, auctions. You can, if you don't have prizes you can give, then give them free time, or give them positive feedback. The Olympiads is something that's been used in the past for challenging the knowledge that they've acquired and for making it a little bit competitive with other students. Be sure that they're ready for that before you just throw them into that. And pre-assessments, I can't stress how useful they are. Especially with adult learners, they do have information they've already acquired. The only way you can find that out is by finding that out. And so give them a little pre-assessment. Don't make them do 35 exercises if they already know how to do it. If they've shown you, they give them a tougher one, they know how to do it, move them on to another concept. But pre-assessments can also be beneficial when comparing with post-assessments. How did you do at the beginning? How did you do at the end? Do you see how far you've come in all the skills that you've acquired? And I would also encourage weekly math challenge, daily math challenge if you can handle it. But just throw something up on the board. It doesn't have to be super math required. It could be anything. In my first session, I did this. What's that? Does anybody see what this is? Right? Anybody see what that is? No? Any ideas? No clues? It's a rectangle. No? No? Oh, okay, you didn't like that one. All right, I'll give you a much nicer one. It doesn't have to be math related, but this, that's pretty straightforward. Yeah? Division, right? Because you're looking out with your D's. No. So, I mean, they can be the, how many. Yeah, yeah, exactly. They can be, right? If it keeps them engaged and it makes them think or, challenges them, yeah, they can be difficult questions too, and like fun little puzzles that they have in the paper or in those little books that you get for the bathroom breaks and you need a challenge or whatever, or those Mensa books or whatever. I mean, students like a challenge, and sometimes they don't feel like doing all the exercises, so they want a little distraction. I'm just going to finish with a quote that I heard at the last Atlantic Conference on Learning Disabilities, which I'll correct because it shouldn't be disabilities, it should be learning differences. And it was Felix Justice who was paraphrasing Martin Luther King in his introduction to Danny Glover, who was there to speak. But it's basically, our learners can never be who they ought to be unless we are who we ought to be. And I mean, it really shows the importance of us as instructors to be who we say we're going to be so that our learners can achieve all the things that we want them to.